Namaste student. Welcome to the video series lectures on periodic table of an element. Today in this series we are going to see a second video on Newland's law of octave. Newland's law of octave. Octave means 8. Octave means 8. So according to Newland's law of octave, whenever we have elements arranged in increasing order of its atomic mass, so I am arranging element in increasing order of its atomic mass, then the physical and chemical properties, the physical and chemical property of every eighth element, the physical and chemical property of every eighth element is similar to that of first element, as like the musical note. We have sa re ga ma pa da ni. These are the sat sur in our Indian musical system. So the eighth sur, we take it as an again sa. So we say sa re ga ma pa da ni sa. So the eighth note and the first note is repeating. So like this here also, when I arrange element in increasing order of its atomic mass, then the property of every eighth element is similar to that of first element. So let me have the series of element here. So let I consider lithium as in first element. So beryllium becomes second, boron becomes third, carbon becomes fourth, nitrogen becomes fifth, oxygen becomes sixth, fluorine becomes seventh, and sodium becomes eighth. So I have the properties of lithium and sodium are similar. Same way, if I take beryllium as in first element, so let me take another color here. Beryllium as in first element, then boron becomes second, carbon becomes third, fourth, fifth, sixth, seventh, eighth. So the property of your beryllium and magnesium will be similar. Now same way, if I try to take it sodium as in first element, this is second, third, fourth, fifth, sixth, seventh, eighth. So sodium and potassium will have same property. So here I can predict here lithium, sodium will have same property. In a similar manner, beryllium, magnesium, calcium will have same property. Boron, aluminium will have same property. So every eighth element in a series will have same property just like that of first element. Now, what are the merits of this Newland's law of octave? Now, here once again Newland tried to correlate the properties of an element with their atomic masses. Now the most important term which he used here, that is periodicity. Periodicity means repetition of property. Periodicity means repetition of properties. So I observe the lithium after a certain fixed interval of a time. When I come to sodium, lithium, sodium will have same property, and that particular duration remains same. Once again, after every eighth element, the property repeats. So there is a term, we call it as in periodicity, the property which repeats itself after a fixed interval of a time. So this is very first time this particular kind of periodicity was been explained in classification. Now, but this classification works very well for lower atomic weight. So for lower atomic weight, till calcium, this classification worked very well. Beyond this, the classification has got some problems. Some problem is it cannot able to correlate the properties with other counterparts, we can say. So what are the limitations we come across for this Newland's law of octave? So the classification fails for the heavier element which are beyond calcium. So beyond calcium, this classification fails to explain. See here, if you look at, when I try to look for the property, suppose if I take potassium as in first, suppose if I take potassium as an first element, then calcium becomes second, this is third, fourth, fifth, sixth, seventh, eighth. Now I cannot correlate the property of potassium with copper because they are far apart. Potassium very reactive, copper is not reactive. If you just drop a piece of potassium metal in water, immediate reaction takes place. But for copper, it will not. So it's been seen that for element above calcium, that is atomic weight more than 40, the classification doesn't hold good. The classification doesn't hold good. Then, with the discovery of noble gases, the idea of octave does not exist, because if I try to place a noble gas in between, then I can correlate that metallic element with noble gases. So here also with octet rule, when your noble gas is coming in picture, this classification doesn't hold good over there. Second, the most important point, it cannot able to provide a specific position to hydrogen. Even this particular problem is persistent in remaining two classification of element like Mendeleev periodic table and modern periodic table. For hydrogen, there is still question mark about the position of element where it has to be. Now iron actually, which resembles in property with cobalt and nickel, they are placed separately. Just look at the classification list here again. Now actually iron possessing same property like that of cobalt and nickel. If I take iron as in first, selenium will come as an eighth one, which do not have similarity in the property. Even if I cannot correlate property of oxygen, sulfur and iron, because oxygen, sulfur are non-metal, iron is a metal. So this classification doesn't hold good beyond atomic weight 40, that is calcium. Hope you must have understood this. Thank you for watching this.